Hello everyone. So in this video we'll try to solve this problem 18 of AMC 2022 12B. So this is also a very interesting problem. So let us try to understand what they are giving in this problem. So we have a 5 cross 5 grid where each square is either filled or empty and has 8 adjacent neighboring square. So why 8? So we'll understand. So when neighboring squares, so squares are neighboring if they either share a side or a corner. So for example, if you consider this square, then 1, 2, 3, 4, 5, 6, 7, 8, all of them are neighboring. So that's why it is saying that up to 8 neighboring square, because this one has only 3 neighboring square. So that's why up to 8. Okay, so then we can transform the grid using the following rules. Any filled square with 2 or 3 filled neighbors remain filled. Okay, so what will I do is, let us try to draw one example. So it's a 5 cross 5. So 1, 2. This is 4 and this is 5. So let us see if it is correct or not. Two, three. Hopefully it will work. Yes. 4 and 5. Right. So let me copy this one. Because we will need it. So now let us go to an example. Okay. So empty I will keep it blank, otherwise I will fill it with this color. Okay, so suppose this is filled, right? And it has 2 or 3 neighbors filled, right? So suppose this one is filled and this one is also filled, right? Then what will happen in the after transformation? So if you see this one, this has one neighbor and this neighbor, so this will remain filled. And this one also have one neighbor and this neighbor, so this will remain filled. And this one also has one neighbor and this neighbor, so this will remain filled. So after the transformation, this is filled, this is filled. Now let us see what happens to the unfilled one. So what they're saying is an empty square with exactly 3 filled neighbors become filled. So for example here, this has 2 filled neighbors, not 3 filled neighbors, so it will be remain blank. So all other squares remain empty or become empty. But if you look at this one, so this one is filled, these 3 things are filled, so this will become filled in the next, in this transformation. So for any other, so here it is only 2, here it is 1, here only 2, same thing, here only 1, here only 1, no other neighbors are. So I think that is the transformation. So let us now try to understand what the problem is. So suppose the 5 cross 5 grid has a border of empty squares surrounding a 3 cross 3 subgrid. So this is a 3 cross 3 subgrid and all of these are empty. How many initial configurations will lead to the transformation which contains only filled square at the center, right? So it says that, so you have filled square, so how many initial configurations are there, so that after you do one transformation, so this filled square will come, right? So let us try with that. So this is our the original this one. So we have two cases, right? So we can have the field one to be, okay, put it down. So we have case one. The middle square is filled in the original one. So filled. So this is the first case. So this is filled, and after this transformation, this is also filled. So this can happen. So it should have 2 or 3 neighbors. That is, so 2 or 3 neighbors that remains filled, right? Okay. So I now use a different color to just differentiate it. So see, let us see. Can we have adjacent things? So we can't have, right? Because we saw in this transformation that if we have adjacent 2 blocks along with this one, so it remains filled. So we can't have adjacent. Okay, let us use this one. Okay, now let us see. Can we have this thing? Okay. So if we consider, let us consider this area. Then what happens is, if you let me use one color. So this one is blank, right? But this has a neighbor, this has a neighbor, and this has a neighbor. So this becomes filled in the next transformation. So whatever is the other, I don't care. So this one will not work, right? So let us do one more case. Okay. So as usual, this middle one is filled, and this one is filled after transformation. Right. Okay, so let us fill the middle one first. Right. So since adjacent ones cannot be filled, so these things are not allowed. These positions are not allowed. Right. So similarly, once this is filled, these positions also not allowed, because if you fill here, then it has 2 adjacent and it will remain filled. Right. Okay. So what happens to this one? So now let us see what happens to the last line, right? So if I fill here, right, this one is empty, but you can see that it has 3 neighbors that are filled, 1, 2, and 3. So this will become filled in the next transformation. So that is also not working, right? So the idea is, in this case, so if we take this one as filled and this one as filled, we can't have this position filled. All these positions cannot be filled, right? So now let us see what happens if we fill these positions. So these 2 positions are not valid, that we have already seen. These 2 positions we can't take, right? So if I take this and this, is it valid? So we can see that after the transformation, so this has only one neighbor, so that will not survive, right? So this has also only one neighbor, so that will not survive. And this is empty, so it needs 3 neighbors to become filled in the next, but it has only 2. So, and that is true for all of them. So this is actually a valid one. Right. So other than that, we will have one more case where you can see that if we put here and here, so same thing will work. So with middle one filled in the original case, the middle is filled, then there are only two cases, only two solutions you can say, or possible configurations. Right, now let us go to the second case that a middle one is empty. Okay, so right, so middle one is empty. I will just use white to denote empty, otherwise it will look completely blank. I'm just changing for this case. So this one is empty, and I want this one to remain empty, right? So we can't have three neighbors, right? Okay, so it's a sorry, so let me so this is empty but this is filled, so we want three neighbors, right? So what we can have is we cannot have adjacent, that I already saw, so we can have these type of things, right? This type of things are possible because each of them has only one neighbor, so it will not survive. But this white one has three neighbors, so that will survive. So if I number these positions, so then it will be, I think, more clearer. This is 5, 6, 7, 8, 9. So these type of things we have 1, 3, 9, 1, 7, 9, 1, 3, 7, 3, 7, 9, right? Okay, so these are the four cases. Okay, so now let us have a different type of things. Okay, so we can have these type of things also. The middle one is there and these things are there. So these are also same story, that it has only one common neighbor each of them, so each of them will not survive, but this has three common neighbors, so that will survive. Okay, so let me write down how many are there. So 2, 7, 9, 6, 1, not 6, 1, so this is 6, right? 6, 3, 9, and then 4, 1, 7, and 8, 1, 3. So these are four more cases. Okay, and now let me draw the other ones. So same thing, so this one is blank, we want it filled. Let me see if we have any other color. Okay, let us use this one. So see, we can have, okay, it is not visible, this one, and this one. This you can have, right? Same idea. So this one has three neighbors, but each of them has only one neighbor. So this is empty, right? This one is blank. So this is only, this is alone. This has only one neighbor. This has also one neighbor, so it is not survive. So this type of things we have how many? 2, 4, 9, 2, 6, 7, 4, 8, 3, and 6, 8, 1. So these are four cases, right? Okay. So now, so to take a new page. Okay, so now since the middle one is empty, so here we can take these two things together, right? Because they have only single neighbor, so it will not be filled in the next transformation. So along this I take this one, so that is also viable, right? So how many cases you have? So you have to choose two out of so you have this line, you have to choose two consecutive, so there are only two ways, right? And you can choose any one of them, so these are four ways. And but once you have fixed this, you have to choose the other one here only, so it is one. So there are 8 cases, 8 solutions. So for the second case, with empty middle, one we have so 4 plus 4 plus 4 and 8, right? 12, 20 possible configurations. Thus total is 2 plus 20, that is 22. So if you see here, so right, so this is solution is C. So the correct option. So hopefully the solution was useful, and subscribe my channel to get more such interesting solutions.